Yes, children, today let us start the session with the properties of periodic table. Okay, now I'm going to start the first property, that is the atomic radius. Okay, so this atomic radius, no, what do you mean by atomic radius? Can you define that? Yes, now it is nothing but the distance between the center of the nucleus of an atom and its outermost shell containing the valence electron. Okay, so if we go across the period, okay, like this. Now I am starting from the lithium, for example. Look at the radius here. It is nothing 167. So when you go to the next row, that is beryllium. Okay, it is an alkaline earth metal. Now look at the radius, it is 112. And when we move to the next element, that is in the same row, boron family, it is the radius is 87. So if you look at the first element, lithium, its radius is 167. When you go to the next row, that is beryllium 112, are you able to see the difference? So the atomic radius decreases. Yes, if you see the boron family, look at the radius, it is 87. Next row, it is the carbon family, the radius is 67, and the next nitrogen family, the radius is 56. So the atomic radius decreases when we move along the period. So from lithium to fluorine, there was a gradual decrease in the atomic radius. Yes, and then when we move down the group, for example, I am moving down in the alkali metals, the next element, sodium. If you look at the radius, it is 190, whereas the lithium, what is the lithium? Lithium is 167. Yes, so the 167 has been increased. For the sodium, the atomic radius is increased. Yes, so when you move down the group, the atomic radius increases. When you move down the group, the atomic radius increases. When you move along the period, the atomic radius decreases. Now, if you see that calcium, the atomic radius decreases, whereas for potassium it is 248, whereas for calcium it is 197. Like that, when you move along the row, the atomic radius decreases. Look at the radius 187. So this is what I am trying to say, that except for the noble gases, no, usually the atomic radius is referred as the covalent radius for the non-metals. Okay, so if you take the non-metals, okay, they are the covalent radius, they will say. Whereas if you take the metals, what happened? It is the alkaline earth metal I have chosen. The radius will be a metallic radius. Okay, so there are covalent means it is the that is post transitional. For example, I'll tell you for non-metal here, nitrogen. So this nitrogen, no, it is a non-metal. So for non-metal, the radius is known as covalent radius, whereas for the metals like beryllium, it is the metallic radius. That's the difference between metallic radius and the covalent radius. And can you define the metallic radius? The metallic radius is nothing but the half the distance between the nuclei of adjacent metal atoms. Okay, it is the half the distance between the nuclei of adjacent metal atoms. Got it? So why this along the period there is a decrease in the atomic radius? Why is it so? Because when you move along the group, for example, again I am taking the lithium, when you move along the group lithium, beryllium, boron, what happened? As the shell number increases, no, what happened? The distance between the valence shell and the nucleus, what happens? It the distances between the valence shell and the cell, it will be more and more of positive charges. So what happened? They will attract the electrons towards them, so that it will shrink the nucleus. That is the distance between the nucleus and the outermost electron, that is outermost orbital or shell. It decreases, the distance decreases. Okay, so which results in the atomic decrease in the atomic size. So that's why the atomic radius also decreases. But for the group, no, when you move down the group, what happened? When you move down the group, there is the increase in the valence shell number itself increases. So what happened? The shell number increases, so the distance between the radius and that is a nucleus and the outermost shell also increases. That's why when you move down the group, the atomic radius increases. When you move along the row, the atomic radius decreases. Got it, children? So that's all about today's class about the atomic radius. We'll see in the next video.